we will be showing you how to measure the following items: a mark holder, a 50 cents coin, a disassembled part of the correction tape, and a bowl.
In this video, we will try to find out as accurate as possible the density of each item. We will not consider the density of paint as
we are all assuming that all these items are made of one material, and we assume all tables' surfaces to be flat.
So here we'll be measuring a cup base, which is a regular object.
First things first, you'll place the cup base against the ruler. We make sure that the cup base is aligned with 0 of the ruler. We do it by checking and looking vertically above it to prevent parallax error.
So we do likewise to the top to record our reading. Remember that the ruler can only measure up to 0.1 cm. So there's no 0.01 cm on our records, even if the end does not actually touch the markings on either side. So thus here we have to round off.
The length that we measured is 9.0 cm, which is equivalent to 90 mm. Repeat the previous steps at least 2 times to get the average readings to minimize human error. So at the end we still get 9.0 cm, equivalent to 90 mm.
So repeat all the above steps to measure the breadth of the mark holder for at least 3 times. So here with these 3 readings, you also calculate another average again. So this time round the breadth is 9.0 cm, equivalent to 90 mm.
Now we'll be using a micrometer to measure its breadth. The micrometer has a precision of 0.01 mm. Now we tighten the anvil and the spindle to check for 0 error by turning the thimble. As observed from this picture, there is 0.00 mm 0 error because the datum line is aligned with 0 on the thimble scale. Place the mark holder between the anvil and the spindle. Turn the ratchet until they are tightened. You will know when the ratchet is tightened when you start to hear slight clicking sounds. So here, the main reading. Here, in order to allow us to be able to actually take a look at the reading, we actually have to ensure that we take a look at both the datum line as well as the thimble reading at the same time. So here, the reading on the main scale is actually 2.0 mm. In this case, we'll label it M. Take the thimble reading that is aligned with the datum line. In this case, it is 0.11 mm, which we will label T. So in order to calculate the entire reading R, we add M and T together. R equals M plus T, whereby R equals 2.0 mm plus 0.11 mm, equivalent to 2.1 mm. Now we calculate the corrected reading by minusing the 0 error from R. So when our 0 error is 0.00 mm, we take 2.11 mm minus 0.00 mm to get the corrected reading of 2.11 mm as well. So here we repeat all the above steps to remeasure the thickness of the mark holder for at least 2 more times, calculating the average of the 3 readings to minimize human error. The average reading is 2.11 mm.
We assume that the mark holder is a regular object and use the formula volume equals length times breadth times thickness. So thus our volume is 90 mm, which is our breadth, 90 mm our length, and the thickness is 2.11 mm, giving us a total of 17,091 mm cubed, which converted to standard form and 3 significant figures is 1.71 times 10 to the power of negative 5 meter cubed.
We shall now be using the electric balance with a precision of 0.1 gram to measure the mass of the mark holder. First things first, we must always
ensure that we actually press the re-zero button or the tear button. This is necessary as the mass balance does not always start with 0. So this is to get a more accurate result. The mass the mark holder has is 6.8 grams. Repeat the steps to obtain the mass of the object for at least another 2 times to get the average reading to minimize human error. And the average mass is 6.8 grams, equivalent to 0.0068 kg.
Using the density formula now, density is equivalent to mass divided by volume. So thus the density of the mark holder is 0.0068 kilograms divided by 1.7091 times 10 to the power of negative 5 meter cube, which gives us a total of 3.98 times 10 to the power of 2 kg over meter cube. Now I'll be measuring the volume, density and mass of the coin. The coin will be our regular object. First things first, we'll clamp the jaws of the vernier calipers together to check for 0 error. zero marks of the two scales coincide. That means that there is no zero error. If it moves slightly to the left, it will be a negative zero error counting from the back starting from 10. If it moves slightly to the right, it will be a positive zero error counting from the front starting from 0. Here, we'll be reading the main scale to the immediate left of the 0 mark of the vernier caliper. In this case, the reading is 2 mm. At the third vernier mark, excluding 0, this coincides with the marking on the main scale. In this case, it is 0.3 mm. So thus, the thickness of the coin, it is the observed reading minus the 0 error. So, it is 2.0 mm plus 0.3 mm minus 0 mm, giving us a total of 2.3 mm. So here we repeat the previous steps, another 2 more readings to get an average reading. This is to reduce the human error as the thickness may not be uniform throughout the entire coin. Here, we'll be repeating the same process for the diameter. We do it 3 times to get the average reading. The diameter to be 23 mm. So here, we'll be repeating the same procedure for the mass of the coin. So as the same procedure as before that we used, for the mark holder, we will be actually using the same procedure now by tearing the thing, getting 0 at the start and then measuring the mass. So here we get the mass to be 6.7 grams. We assume that the coin is a regular object and thus we use the formula volume equals 2 diameter over 2 square times pi times thickness. So here we get 23 divided by 2 square times pi times 2.3 mm, giving us a total of 955.59 mm cubed. So by converting it to 3 significant figures as well as standard form, 9.5559 times 10 to the power of negative 7 meter cubed. So using the density formula, we shall be getting the density equals mass over volume. So thus, the mass would be 0.0067 kg divided by the volume, which is 9.5559 times 10 to the power of negative 7 meter cubed, giving us a total of 7.01 times 10 kilograms over meter cubed.
Now, we will use this measuring cylinder to measure the volume of a disassembled part of a correction tape, which is an irregular object. Read the markings on the measuring cylinder while the eye is perpendicular to the cylinder, and read at the bottom of the meniscus. Record the initial volume of water. Also, place your measuring cylinder on a flat surface. From the actual picture, the initial volume of water is 82 cm cubed. In the experiment, we do not take into consideration of the water evaporated. Place the disassembled correction tape into the measuring cylinder gently to prevent water from splashing out and sticking to the sides of the measuring cylinder. The towel is to be prepared in case of spillage. Remove the towel. Likewise, read the new reading by placing your eye perpendicular to the cylinder. The new reading is 86 cm cubed. Volume of the object is 4 cm cubed. Now, place the disassembled correction tape on the electronic balance and record down its mass. The mass of the disassembled correction tape is 5.7 grams. The density of the disassembled correction tape is 1.425 times 10 to the power of 3 kg per meter cube.
Our last item is a bowl, which is a difficult item to measure. Now you need to have a definite amount of water prepared to be used to fill the bowl to find the interior volume of the bowl. The beaker contains 200 cm³ of water.
The measuring cylinder contains 100 cm³ of water. Now we will start pouring water into the bowl. We start with 2 beakers of water and continues by pouring in water using the measuring cylinder. After the bowl is filled, the last measuring cylinder contains 100 cm³ of water. We have used 2 beakers and 3 measuring cylinders, but left with 100 cm³ of water. The volume of water used is equals to 690 cm³ of water. Now we will try to find the entire volume of the bowl. First, trace the circumference of the mouth of the bowl. After which, mark out any 2 points on the circumference. From the 2 points, draw 2 intersection points using your compass. Join the 2 intersection points together. That lines that joins the 2 points together cuts the circle into half. Allow me to. So from the picture, you are actually able to see an analogy of how this can work. From the picture, you can see that A and C is not at the same plane. There is any 2 points that you can find on the circumference. From there, you derive the 2 circles, which is drawn or which is indicated by the yellow color circle. And you can see actually from the yellow color circle, it forms 2 intersection points B and D. And from that, we can actually form a kite shape A, B, C, D. And from the kite shape, we are actually able to derive that from A to E and E to C is actually equal to each other. So which means that BD actually divides the circle into half. For more detailed explanation, please read through the mathematical equation at the side that shows you the logic of how it explains. Now we will measure the diameter of the circle. The precaution is the same as how we measure the length of the mark holder. The diameter of the mouth of the bowl is 14 cm. Repeat the same process to get the base. So previously you used the mouth, now you use the base, and the process is the same. And from there you can actually get the diameter of the base, which is 7.8 cm. Place the set square against the bowl. Using the protractor, align the set square to 90 degrees. This is to ensure that the set square is upright against the bowl and perpendicular to the table, so that the height achieved is the height that is formed from a right angle instead of a slant height. The edge touches the 7.1 cm marking. Taking into consideration that the set square has a small empty space, we measure the set square using a ruler. to include the empty space. The height of the bowl is 7.4 cm. This is the formula to get the volume of frustum. Use the height times pi over 3 times square of base radius plus base radius times the top radius and the square of top radius.
The volume of the bowl, excluding the empty area, is to use the volume of the frustum minus away the volume of water which we use to fill out the entire bowl. Therefore, the final volume is 0.000072314 meter cube.
Again, measuring the mass of the bowl, precaution is the same for it, and the mass of the bowl is 109.9 gram, or it can be also expressed as 0.1099 kilogram. After that, use the well-known formula of density, mass over volume to get the density. The density of the bowl is 1.52 times 10 to the power of 3 kilogram meter cube. Finally, this is a summary of the density of all the 4 items that we have achieved through the video. Thank you very much.